Hello everyone, welcome to today's session. Today we are going to learn an important concept in optics, that is critical angle. What is critical angle? What are the factors affecting critical angle C? What is the relationship between critical angle and refractive index? These are the today's topic of discussion. Okay, well, before we learn about critical angle, let us consider the case of refraction taking place from a denser medium from glass to air. Let us consider the case number 1. So here a ray of light AO traveling in glass and is incidenting at the glass air interface. This is the surface of separation between glass and air at a small angle of incidence. The angle of incidence is small. As you can see, the incident ray, when it is emerging from denser medium to rarer medium, it is partly getting reflected along OC and it is partly getting refracted along OB, such that we get a strong refracted ray OB and a weak reflected ray OC. Since the ray of light is traveling from denser medium to rarer medium, it is bending away from the normal. Okay, fine. Now, you slightly increase the angle of incidence. If you increase the angle of incidence, which is represented in red, you can see that the angle of refraction is also going on increasing. If you slightly increase the angle of incidence, angle of refraction is also going on increasing. You can see on the diagram. Okay. Now consider the case number 2. Now you keep on increasing the angle of incidence. You gradually increase the angle of incidence. And what is the angle of refraction in the rarer medium? So the angle of, if you increase the angle of incidence such that the angle of refraction in the rarer medium becomes maximum, that is angle R is equal to 90 degree, and you can see that the refracted ray OB is passing along the surface of separation between glass and air. It is called grazing emergence. We call it as grazing emergence. This is called grazing emergence. Or you can see the light ray, the refracted ray OB is passing along the periphery of surface of separation between glass and air. It is called a grazing emergence. I can write grazing emergence. Okay, grazing emergence. So at a particular value of angle of incidence in the denser medium, the angle of refraction in the rarer medium becomes 90, as you can see on the diagram. So this particular value of angle of incidence corresponding to which the angle of refraction is 90 in the rarer medium, we can call it as critical angle. Critical angle C. So here I can write angle of incidence, a particular angle of incidence which is equal to critical angle, corresponding to which the angle of refraction is 90 or maximum in the rarer medium. We call it as critical angle. Okay, so what is critical angle? So critical angle is the angle of incidence in the denser medium. In the denser medium, corresponding to which the angle of refraction in the rarer medium, is 90 degree. That we call it as critical angle. Alright, so in the critical angle, at critical angle, what is happening here? The refracted ray is passing along the periphery of surface of separation between glass and air. This is known as grazing emergence. What is that? Grazing emergence. Alright, and we get a weak refracted ray along OB and a strong reflected ray along OC. Okay, now if you, in the third case, if you increase the angle of incidence greater than critical angle, what will happen? The angle of incidence is such that it is greater than critical angle, what will happen? Now you can imagine what will happen. Look at the pattern. If you keep on increasing the angle of incidence, angle of refraction going on increasing, and at a particular value of angle of incidence, the angle of refraction in the rare medium becomes a maximum, and now you are increasing the angle of incidence beyond the value of critical angle, angle of incidence greater than critical angle, what will happen? So instead of refraction, there won't be any refracted ray, it will be reflected back to the medium. That's a special case of total internal reflection that we will learn in the next schedule. Okay, so our topic is what is critical angle. So we will focus on this diagram. Alright, so as you can see, critical angle corresponding to which angle of refraction is 90 degree. Okay, is it fine? Clear? Now let's see what are the factors affecting the value of critical angle. Definitely, the value of critical angle for a given pair of media depends on the refractive indices of the given pair of media. In our case, what is the given pair of media? Glass and air. So remember, the refraction is taking place from denser medium to rarer medium. So the refractive index of a medium is affected by two factors. You know it. What all are they? The color or wavelength of the light and the temperature. Since the refractive index is affected by color and temperature, therefore I can say the critical angle also must be affected by color of the light and temperature. So the first factor affecting critical angle is I can write color or the wavelength lambda of the given light. Okay, so you know that the dependence of color or wavelength on the refractive index of a medium. The refractive index of a transparent medium decreases with increase in wavelength. Alright, so refractive index is inversely proportional to the wavelength. You know it, you have already studied. So I can say that it is most for the violet light whose wavelength is least, the refractive index will be maximum, and it is least for the red light whose wavelength is maximum. Therefore I can say that the critical angle for a pair of media is least for violet light and the most for red light. Alright, so I can say the critical angle increases with increase in wavelength of the light. The critical angle is directly proportional to wavelength of the light. So remember, critical angle increases with increase in wavelength, such that the critical angle for a pair of media is least for violet. So critical angle C is least for violet and C is maximum for red. Alright, please remember, critical angle is directly proportional to wavelength, such that critical angle is least for violet and critical angle is maximum for red. Then the second factor controlling the refractive index mainly depends on temperature. Therefore Critical angle also will be strongly affected by temperature. How the temperature affects the critical angle? You know, as the temperature increases, the refractive index also, medium also increases. So we can say the critical angle increases with the increase in temperature. So the critical angle is directly proportional to temperature. The critical angle also increases with increase in temperature. So remember these two factors. Critical angle is directly proportional to wavelength. Critical angle increases with increase in wavelength. Critical angle increases with increase in temperature. Please remember these two factors on which critical angle C depends. Clear? Fine. Now let's study what is the relationship between critical angle C and refractive index mu of a given medium. For that we will consider the case number 2. You can see the refraction is taking place from denser medium to rarer medium at a particular angle of incidence which is equal to critical angle. The angle of refraction is maximum, which is equal to 90 degree. So what is the relationship between critical angle C and the refractive index of this pair of media? It's very simple as a straight line. Just apply the Snell's law in this case and see. Let us see what is the result of applying Snell's law here. So according to Snell's law, the refractive index of a medium 2 with respect to 1. So remember that the refraction is taking place from glass to air. So the refractive index of the second medium, refractive index of the air with respect to glass is equal to sine of angle of incidence in the first medium. So what is the sine of angle of incidence? Sine I by sine R. Okay, all right. Now let us consider the special case of angle I and R here. So refractive index of air with respect to glass is equal to sine I. What is I? Angle of incidence is equal to critical angle C divided by sine R. What is R? What is the value of R here? Sine 90. Alright. You know the value of sine 90 is equal to 1. So I can write refractive index of air with respect to glass is equal to sine C, sine of critical angle. Okay. Is it clear up to here? Now, this is the refractive index of air with respect to glass. We need to find out the refractive index, so the critical angle for glass air interface. Alright, glass, this is glass air interface. So what is the refractive? If you know the refractive index of air with respect to glass, you know what is the refractive index of glass with respect to air? Just to take the reciprocal of that. Okay, 1 by refractive index of air with respect to glass. You know it. Refractive index of air with respect to glass. If you know it, what is the refractive index of glass with respect to air? Just reciprocal it. Okay, take the reciprocal of it. So I can write refractive index of glass with respect to air is equal to 1 divided by, what is refractive index of air with respect to glass? The value is given there, 1 by sine C. It is already given there. So in the denominator put sine C. Okay. Or I can write from here sine C is equal to 1 by refractive index of glass with respect to air. So very important relation. Sine of critical angle is equal to 1 by refractive index of glass with respect to air. Okay. So 1 by sine C, it is also can be written as cosec C. Okay, 1 by sine theta is equal to cosec theta. You know the relation in trigonometry. So sine C is equal to, we are getting it as 1 by or the reciprocal of refractive index of air with respect to glass. Okay. Thus, knowing the refractive index of any denser medium. So if you know the value of refractive index of glass with respect to a rarer medium, we can easily calculate the critical angle for that particular pair of media. What is the pair of media here? Glass and air. For example, you know the refractive index of glass, you know the value is equal to 3 by 2. That is equal to 1 by 5. You know it. So sine C, sine of critical angle is equal to 1 by refractive index of glass with respect to air. That is equal to sine C 1 by, what is that? 3 by 2. So I can write sine C is equal to 2 by 3. So sine C is equal to 2 by 3. The value of sine theta corresponding to 2 by 3 value, I am getting it as sine 42 is equal to 42 degree is equal to 2 by 3. Therefore, I can write the critical angle for glass air interface, the value of sine 42 coming as 2 by 3 in the logarithmic table. I can write C, critical angle is equal to 42 degree. So for glass air interface, the critical angle is coming as, you can see here as 42 degree. All right. Okay. So for glass, refractive index of glass is equal to 1.5 and the critical angle for glass, we are getting it as 42 degree, and the refractive index of water is 1.33 and the critical angle for water, it is coming it as 49 degree, and the refractive index of diamond is almost 2.4 and the critical angle for diamond is coming it as 24 degree. So what do you observe here? As the refractive index increases, the critical angle going on decreasing. Okay, so as the refractive index increases, critical angle decreases. Okay, very important conclusion. These are some of the experimentally calculated value. So this is the relation between critical angle and refractive index of a pair of media. Sin C, sine of critical angle, is equal to 1 by or refractive index of that glass with respect to air, or 1 by the refractive index of that pair of media or denser medium. So if you know the refractive index of a denser medium, we can easily calculate the critical angle for that particular pair of media. Is it clear? Okay, thank you very much.